So I thought it would be helpful before you started this assignment if I went over a couple examples for you, and then you could do the remainder of the problems on your own. So today you'll be doing a classwork assignment that are from lessons 8.1 and 8.2. Besides me doing these examples, your class notes for these lessons are a great reference as well. The first page, 1 through 9, correlates with lesson 8.2. It says solve the exponential equation. Remember, both sides of the equation must be rewritten with the same base. Okay, so let's see. There's 9 problems here. How about if I do, let me do number 2. And then we'll choose one more in this section to help you out as well. So number 2 says 4 to the 2x plus 1 equals 16. So the first thing I need to do is have the same bases, and I don't. I have a base 4 on the left and a 16 on the right. But I do know that 16 can be written with a base of 4. It's actually 4 squared. So excuse me, so now I have 4 to the 2x plus 1 equals 4 to the second power. Remember, once you have the same base, those go away and you just set up your exponents equal to each other. So I'm going to subtract 1. I have 2x equals 1, and then I divide by 2, and x equals 1/2. That means if I put 1/2 back in for x, it would make that true. Okay, let's look at another one. Okay, how about if I do number 16 with you? Not 16, how about number 9? Number 9 says 64x to the x plus 1 power equals 16 to the 2x minus 3 power. Again, I have to have the same bases. Neither 64 or 16 have the same basis. So I'm going to look at the smaller base first, the 16. And I'm going to think about perfect squares or perfect cubes for 16. I do know that 4 squared is 16. So if I think about another group of 4, I know that 4 to the third power is 64. Now, I've replaced 16 with 4 squared. I still have to bring down this 2x minus 3. I've replaced 64 with 4 cubed. I still have to bring down the x plus 1. It's coming down. So now I have 4 to the 3 times x plus 1 power equals 4 to the 2 times 2x minus 3 power. Now that I have the same base, I take and rewrite just my exponents. 3 times the sum of x and 1 equals 2 times 2x minus 3. I distribute my 3 on the left. I get 3x plus 3 equals, and my 2, I distribute that on the right. 4x minus 6. I think I'll subtract my 3 and I'll add my 6. And when I do, I get the 3 x's are gone. 3 plus 6 equals 9. 4x minus 3x is x, and negative 6 plus 6 is gone. So I get x equals 9. Again, I can put that in to solve. Okay, now you should be on the second page. The second page, numbers 10 through 14 go with lesson 8.1. I believe everything left on this, so 10 through 19 are all part of your lesson 8.1 notes. All right, so I'll choose number 14 to do with you. And number 14 says 27 to the negative 1/3 power. So to simplify it, this is in exponential form. I'm going to turn it into radical form and possibly simplify it from there. So this is my exponent when I put it in radical form. This is my root. So this becomes the cube root of 27 to the negative 1 power. if I look at my perfect cube charts, 27 is a perfect cube. It's 3, so now I have 3 to the negative 1 power. I am not simplified. If I have a negative exponent, it's going to drop to the bottom, and so it's going to be 1 over 3 to the positive 1 power, or just 1/3, because that's what that means. Okay. Let's look at number 16. These are in radical form. They want us to write it in exponential form. So 16 is the square root of g to the 12 h to the negative 4. So I know one of my bases is g. The exponent on g is 12, and the root, since there's nothing there, is square root. H is a base, the exponent's negative 4, and the root is 2, since there's nothing there. I can simplify g to the 12 halves, it's 6. I can simplify h to the negative 4 halves, it's negative 2. But I'm not done. Why? Because you cannot have negative exponents. It means that this is going to the denominator, this whole thing. What stays? G to the 6 stays in the numerator. The denominator becomes h to the positive second power. So your answer is g to the 6 divided by h squared. Okay. Numbers 18 and 19 you're solving. That means for 18, 5x to the 1/3 power equals 20. I want to get x by itself. And right now with it, I have 5 times x to the 1/3 power. So to undo multiplication, I'm going to divide. When I divide, I'm left with x to the 1/3 power equals 4. How do I get rid of the 1/3 power so I just have x? I multiply by the reciprocal. And the reciprocal of 1/3 is 3, or 3 over 1. These all become 1, and I get x equals 4 to the 3rd power. And 4 to the 3rd power is 4 times 4 times 4, or 64. Okay, so what you're going to do is complete the remainder of these problems that we did not do together. So that would be 1, 3, 4, 5, 6. Well, and then it looks like 7 was labeled as 5. So let's go back. 1, 3, 4, 5, 6, 7, 8. On the second page, 10, 11, 12, 13, 15, 17, and 19. Once you finish those, submit them. It is a classwork assignment, and always remember to watch your due dates. If you have any questions or need help with any of these, please message me. Hope you all have a great day.